Welcome back to the Master Your Science channel. We are continuing with our Master Your Chemistry series. Today we'll be looking at the IGCSE Chemistry Topic 2, Atoms, Elements, and Compounds. Section 2.1, Elements, Compounds, and Mixtures. According to the IGCSE Cambridge Syllabus for examination from 2026 to 2028, by the end of this topic, you should be able to describe the difference between elements, compounds, and mixtures. So what is the difference between elements, compounds, and mixtures? An element is a pure substance that is made up of only one type of atom and cannot be broken down into anything simpler by chemical means. A compound is also a pure substance made up of two or more elements that are chemically combined, and some compounds can be decomposed. A mixture is an impure substance that is made up of two or more elements and or compounds physically combined. These can be physically separated into individual elements and or compounds. Okay, this diagram shows an element, so that's made up of only one type of atom. This diagram also shows an element because this molecule is made up of only one type of atom. So in this case, we could have an example would be your oxygen. So oxygen is diatomic. Oxygen would be an element even though it's made up of molecules, but they are all of the same type of atoms. This diagram shows a compound, so that's made up of two different elements combined, and this is a pure substance. And this diagram now shows a mixture because we've got a compound in there. So this is a compound, then this is an element, and this is also an element. So this is a mixture of two elements and a compound. The following question is from a Cambridge past exam paper. It states, which statements about clean dry air are correct? Number 1, it is a mixture of elements only. Number 2, it is a mixture of elements and compounds. Number 3, it only contains non-metals. So what exactly constitutes clean dry air? Clean dry air constitutes about 78% nitrogen, 21% oxygen, and the remaining 1% consists of trace gases that include argon, carbon dioxide, neon, helium, methane, krypton, and hydrogen, among others. So let's revisit our answers here. Number 1 says it is a mixture of elements only. So this is incorrect because we've got compounds like carbon dioxide and methane in our trace compounds within the constituency of our clean dry air. So 1 is incorrect. So that eliminates these first two answers. Then it says it is a mixture of elements and compounds, so that is correct. As we've said, there are elements which are nitrogen, oxygen, neon, helium, and then we've got compounds such as carbon dioxide and methane. So number 2 is correct. The number 3 says it contains only non-metals. So that also is correct because none of the elements we've mentioned are metals, so that is correct. So that makes C the correct answer. Section 2.2, Atomic Structure and the Periodic Table. According to the IGCSE Cambridge Syllabus for examination from 2026 to 2028, by the end of this topic, you should be able to do the following. Number 1, describe the structure of an atom. Number 2, state the relative charges and relative masses of a proton, a neutron, and an electron. Number 3, define proton number or atomic number. Number 4, define mass number or nucleon number. Number 5, determine the electronic configuration of elements in their ions with proton number 1 to 20. Number 6, state that A, group 7 noble gases have a full outer electron shell. B, the number of outer shell electrons is equal to the group number in groups 1 to 7. And C, the number of occupied electron shells is equal to the period number. The following question is taken from a Cambridge first exam paper, and it says a representation of an atom is shown. What is the nuclear number of this atom? So the nuclear number, by definition, is the total number of protons and neutrons in the nucleus of an atom. Then the proton number is the total number of protons in the nucleus of an atom. So in this case, we need the total number of protons and neutrons in the nucleus of the atom. And the nucleus is right at the center of an atom. And in this case, that would be right here. That is our center. And then surrounding that center are electrons. So in this representation, we would have our electrons. These are all electrons, and they are shown as negative charges because electrons are negatively charged while protons are positively charged. Neutrons are neutral, they have no charge. So the nuclear number of this atom, we have to count the number of protons and neutrons in the nucleus. So that will give us 18. So feel free to pause this video and see whether that is correct. And this next question says, an atom of element X contains 5 protons, 6 neutrons, and 5 electrons. Which statements about element X are correct? Number 1 says X is an atomic number of 6. Number 2 says X is a nuclear number of 11. Number 3, X is in group 2 of the periodic table. And number 4, X is in the second period of the periodic table. Okay, let us examine these statements. So the first one says X is an atomic number of 6. So atomic number is the other name for proton number. And the number of protons according to that statement is 5. So that makes this statement incorrect. Then the next statement says X is a nucleon number of 11. Nucleon number is also known as the mass number. And that's the total number of neutrons and protons in the nucleus of an atom. So that gives us 6 plus plus 5, which is equal to 11. So that is a correct statement. Then number 3 says X is in group 2 of the periodic table. So the group number would be equal to the number of electrons in the outermost shell. So this element has 5 electrons, which means its outermost shell would have 3 electrons. So this is an incorrect statement. 2.3 here would be the electronic configuration of an element that is 5 electrons. Then number 4 says X is in the second period of the periodic table. So the period number is equal to the number of occupied electron shells, and in this case, from the electronic configuration, we can see we've got 1, 2 occupied electron shells. So 2 occupied electron shells means we are in period 2, which is the second period of the periodic table. So that makes this statement correct. So we've got 2 and 4 being the correct statements, which makes D the correct answer. Okay, this next question says magnesium, calcium, and strontium are group 2 elements. Part A says complete table 2.1 to show the electronic configuration of a calcium atom. So a calcium atom has a proton number of 20. For an atom, the number of protons equals the number of electrons because it's neutral. So it means the number of electrons for a calcium atom is 20. So to fill up the first shell, we need 2 electrons. Then the second shell will need 8 electrons. The third shell will also need 8 electrons. And at this point, we've used up 18 electrons, which means the last shell we have 2 electrons. So that would be the electronic configuration of a calcium atom. Then part B says describe how the electronic configuration of a strontium atom is similar to the electronic configuration of a calcium atom. So these are both group 2 elements, which means they will both have 2 electrons in their outermost shell. So that is how they are similar in their electronic configuration. So 2 electrons in the outermost shell. And then the second part says how the electronic configuration of a strontium atom is different from the electronic configuration of a calcium atom. So strontium is going to have more electrons compared to the calcium atom, and so it will fall in a different period compared to the calcium atom. So it has more. So how the electronic configuration will differ? They will differ in the number of shells. This question is also a Cambridge past exam paper. It says Table 1.1 gives the electronic configuration of some atoms and ions A to G. Then answer the following questions about A to G. Each letter may be used once, more than once, or not at all. State which of the atoms or ions A to G could be a noble gas atom. So, noble gases are a special class of gases. These have full outermost shells. So, we've got a noble gas such as helium, which is a full outermost shell, which is full with only 2 electrons. And then we've got neon argon, which have a full outer shell with 8 electrons. So noble gases are stable and unreactive because they have full outermost shells. As you will remember, other elements are able to react because they have incomplete outermost shells, so they are able to either receive or give electrons. But for noble gases, those outermost shells are already fully occupied, so they do not react. So this question is only asking which of those is a noble gas. So if we look at what we are given, only B shows a complete outermost shell. Which has 8 electrons in the outermost shell. So the correct answer here would be B. Okay, let's look at this question also from a past exam paper. It says, which statements about the position of the elements in the periodic table are correct? Elements in the same group have similar chemical properties, so that would be correct. Then elements in the same period have similar chemical properties. That is a false statement. Then number 3, elements in the same group have the same number of electron shells. That is a false statement. The number 4 says elements in the same group have the same number of outer shell electrons. So this is correct, and it's actually the reason why they display similar chemical properties. So the correct answer is B. Section 2.3, Isotopes. According to the IGCSE Cambridge Syllabus for examination from 2026 to 2028, by the end of this topic, you should be able to define isotopes. Number 2, interpret and use symbols for atoms. Number 3, state that isotopes of the same element have the same chemical properties because they have the same number of electrons and therefore the same electronic configuration. Number 4, calculate the relative atomic mass of an element from the relative masses and abundances of its isotopes. So what are isotopes? So isotopes are atoms of the same element which have the same proton number but different mass number. So essentially kana chitaura nezvemaisotopes, you can picture kana muguri wechibage. Pasame muguri wechibage ipapo you find kuti some grains are bigger than others, but hazvichinje kuti chibage. So chibage chingori chibage regardless of how much bigger the other grain is to the other, it still remains chibage. So it's the same thing nema isotopes. So they are still my atoms, they are still the exact same element as kuti their mass numbers are now different. So that's the analogy I can give you about isotopes. So this question here says an element T has two isotopes, T12, T14. Which statement about these isotopes is correct? A says they have different chemical properties because they have different numbers of neutrons. So chemical properties are determined by the number of electrons in the outermost shell. So this statement is incorrect. Then the second statement says they have the same chemical properties because they have the same number of outer shell electrons. So that is true because they are the same element, they have the same number of electrons in their outer shell. Then they have the same nucleon number because the sum of the number of protons and electrons is the same. Nucleon number is actually the sum of protons and neutrons, not protons and electrons. So this is incorrect. And they have different positions in the periodic table because they have different numbers of neutrons. And this also again is incorrect because the position in the periodic table is determined by the proton number. So B is the correct answer. Okay, number 3 says rubidium has two isotopes, rubidium 85 and rubidium 87. Which statement explains why both isotopes have the same chemical properties? As we've just discussed, chemical properties are determined by the electrons, the number of electrons in the outermost shell. So it has to do with electronic configuration. So from the answers we have here, it says part A, they have the same number of protons, so this is incorrect. They do have the same number of protons, but that is not why they have the same chemical properties. Then part B says they have the same electronic configuration, so this is correct. C says they have different number of neutrons. Yes, they do have different numbers of neutrons, but that is not why they have the same chemical properties. They have different mass numbers. This is also correct. They have different mass numbers, but this is not why they have the same chemical properties. So B is the correct answer. This question is also taken from a Cambridge first exam paper, and it says which information is needed to calculate the relative atomic mass of an element. So the first answer says the total number of protons and neutrons in the most abundant isotope. This is incorrect. The nucleon numbers and the total number of isotopes. This also is incorrect. Then C says the mass number and the abundance of each of its isotopes. So this would be correct. Then D says the atomic number and abundance of its isotopes. So this is incorrect because the atomic number is actually your proton number, and the proton number is the same for the isotopes because they are the same element. This question says table 2.2 shows the relative abundance of the two naturally occurring isotopes of copper. Calculate the relative atomic mass of copper to 1 decimal place. So the relative atomic mass is the average mass of the isotopes of an element compared to 1/12 of the mass of an atom of carbon 12. So in this case, we know that copper 63 has a relative abundance of 70%, copper 65 has a relative abundance of 30%. So this figure, which is your 63 and 65, is representing your mass number. So for copper 63, which is 70%, so say our 63 times 70 plus 65 times 30, and we'll divide this by the total, which is 100. This gives us an answer of 63.6. Thank you for watching until the end. I hope you found this video very helpful in your studies, in your revision as you go on with your chemistry studies. Please subscribe, like, and share this video. And if you would like to contact me for online lessons, you may find my WhatsApp number in the comment below. Thank you so much for your support. Goodbye. Till next time.